this is a quick Arctic sea ice update. These graphs and images that I've used here you can find available freely online, and I'll link to them in the description. So 2013 had a higher winter maximum than in previous years for extent, and extent is a concentration of ice that includes low concentrations below 30%, whereas area is higher concentrations. But the area and extent graph tend to be fairly similar, although not identical. So at the moment we're higher than in previous years, but you can see that this grey area indicates the two standard deviations. So this dark grey line is the mean, and this lighter grey area represents two standard deviations from the mean. So you can see that we're still quite a long way below average. Of course, this isn't as important as the volume, which I'll come to in a second. But in terms of sea ice extent, we're higher than we are in previous years. And one of the reasons that this might be is because of meteorological conditions that have been happening recently. There's been something that's been nicknamed PAC 2013, which stands for Persistent Arctic Cyclone. So there's been an Arctic cyclone that's lasted for several weeks during the month of May and June, where an area of low pressure sat roughly over the North Pole for quite a few weeks, and this had several effects on the ice. Firstly, it means that the weather tends to be colder and also cloudier, and those two things sort of come hand in hand, because when you get more cloud, there's less solar radiation instant on the Arctic ice, so things tend to be cooler. And also there was more snowfall than one would usually expect at this time of year because of the low pressure area, the persistent low pressure area. So the Arctic was cooler than usual in the central basin, although it was actually warmer than usual along the coasts, particularly northern Alaska and northern Siberia. So this is one of the reasons why the extent is high, because there's not been a lot of solar radiation to spur the melting on. But also another reason is that low pressure areas over the Arctic cause the ice to diverge, that is to split up into lower concentration and smaller flows, and this causes the ice to fill a bigger area, so the extent is bigger. And usually the cold cool effects of the Arctic cyclones tend to dominate over the fact that the ice is diverging, which is a negative effect, because it means that later on in the summer, when you do get more solar radiation, the lower concentration is likely to melt faster. But generally, cyclones are good for the ice, because the cloud in particular tends to override these effects. But it's worth noting that there are negative effects of cyclones as well. For example, there's a process called Ekman swelling, which is caused by low pressure areas, where warmer water from deeper in the ocean comes towards the surface, and it helps to melt the ice from the bottom. And low pressure areas in general cause more sort of swell action from the waves, and which tend to break up the ice into smaller chunks. But there's been a few research papers done on this, and it tends to be the fact that summers that are dominated by cyclones tend to favour ice retention rather than ice melt, in comparison to the previous year. Although it's worth noting that since the ice is so thin these days, we can't take that for granted, so it's something to bear in mind. So the fact that the ice extent is much higher than it was a few years ago doesn't necessarily mean it's going to stay that way, and we might see a cliff sooner or later. The low pressure area is now starting to dissipate, and we're expecting a ridge of high pressure to start to come towards the North Pole, which means more sunlight, more ice melt. So that's something to take into account. The image on the right is the biomass. Biomass is an Arctic sea ice model, and this models the volume of the Arctic sea ice, which is a far more useful measure than extent alone, although extent is easier to measure, which is why we still use it. It can be measured directly from satellites, whereas this is much harder to get an accurate indicator of what the volume is. So it's worth noting that the error bars on this graph will be quite large in comparison to this one. Also, it is true that there are different satellites that measure extents slightly differently, but in this case, this is a model rather than a direct measure. So actually, 2013 is slightly above 2012, which is something that I perhaps wasn't expecting. I was probably expecting 2013 to be another record low, but to be honest, it's fairly trivial, because it's still the second or third lowest in the satellite record, well, since biomass started anyway. So it's still dreadfully below average. We're still way below the mean. So the volume is still pretty low, but it's a cause for optimism that it isn't the lowest it's ever been, unlike it was last year. Okay, so what's the spatial distribution of the Arctic sea ice? Okay, so this is from the MRS-2 satellite. I hope I've said that right. I might have said the letters a bit too fast. The AMSR satellite. So this is one of the higher resolutions satellites that shows the concentration of the Arctic sea ice. So this is measuring concentration. So the purple colours represent higher concentration, and the yellows represent much lower concentration. And you can see that in the North Pole area the concentration is quite low because of this persistent Arctic cyclone, which has tended to break up the ice somewhat. This image on the right is one that I made, and it's supposed to represent an indication of what the thickness is. What I've tried to do is I've tried to take lots of different models, and I'll link to those in the description, of the spatial distribution of the ice, and then I've sort of added in, compared these with actual observations of the sea ice. In particular, we have mass balance buoys that can tell us specifically how thick the ice is in certain places. Because I tend to find that the models seem to overdo how thick the ice is. They tend to make it a few meters thicker. So this is a combination of the spatial distribution indicated by the models and how thick that we've actually measured it to be. So blue is ice that's more than 1 metre thick, green is 2 metres, and red is 3 metres. So the ice is, again, still fairly thin, and most of it is first year or second year ice, although there's still quite a large amount of multi-year ice in the Canadian archipelago left there. I've actually made a prediction, like I did last year, for 2013. The lowest ice extent, the minimum, tends to be in early September. Last year it was the 9th, so I've got this image of last year's, and this is my prediction for this year's. I think it's actually going to be very similar to last year. I think the fact that we've got high extent at the moment isn't going to stop it from dropping rapidly, due to the fact that the ice is very thin, and also the fact that the cyclone has been brought the concentration down. So despite the fact that we've had a lot of cool and cloudy weather at the moment, I don't think it's going to last. The long-range forecast suggests that we are still likely to see some below-average temperatures through July and August in the Arctic basin, but it also suggests that in particular in August we are likely to also see some areas of high pressure that are going to bring some solar radiation into the Arctic, more than we would want. So I think that given how thin that the ice is, taken with the projections about where the ice should be in a couple of years' time. So these are based on the trend lines. So the mathematical trends. I think you can see if you Google the various sea ice trends, then you can see some of the mathematical models used. For example, exponential, linear, and there are some better ones. So based on a few different things, this is what I think 2013 is going to look like. Very similar to 2012 actually. The Canadian archipelago is going to see the high concentration ice. So this is my concentration. So blue tends to be low concentration, 30%, 30 to 50%. Green is a little bit higher, so 50 to 70%, and then red is the highest, higher concentration stuff. So this is my prediction for start of September, the minimum extent this year, and I think it will be early September. We're looking at about the same time as last year. So Northwest Passage is going to be open, I'm pretty sure about that, and I'm also pretty sure that the Northeast Passage is going to be open. Much more sure than I was last year actually. Last year obviously both passages did become open. So I don't think we'll see quite as low an extent as we did last year. If I had to try and point to this graph where I think it would be, I think we're going to be somewhere in between 2012 and I don't think 2007 isn't on here, but 2011 is. So somewhere in between these two lines, I think maybe somewhere around here. I don't think we'll actually get to 2012 again this year, because during the month of May and June the conditions have have been cyclonic, which is supposed to be good for ice retention, even though there are mitigating factors that I mentioned. So my prediction would be somewhere in between 2012 and 2007, perhaps very similar to 2007, but with this spatial distribution here. Both passages will be open, but the northeast passage will only be open for quite a short while compared to much longer times than it was open last year. So that's my amateur thoughts on the sea ice. I'm by no means an expert, so if anyone is more knowledgeable on the sea ice, I'd appreciate to hear some thoughts from them. Anyway, that's my rough prediction about what's going to happen this year.